Hey, welcome back to Math with Patrick. Today is July 10th, and we're solving problem number 191 from the Daily Epsilon calendar. And we need to show what the product is of 6 factorial and 7 factorial. And apparently it's equal to another factorial number here. Just a quick definition of a factorial. I guess I'll go example first. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. It is a product, or a bunch of things being multiplied, of your beginning number and all of the natural numbers down to 1. That last times 1 doesn't really do much because multiplying by 1 doesn't change the value of anything, but kind of by definition we have the times 1 there. So 6 factorial is just going to be 6 times the previous one. That's another way to think about factorials, is in a recursive sense, where you take 6 times and then just do the factorial of the previous number, which would, for this one, be times 5 times 4 times 3 times 2 times 1. 7 factorial follows the same pattern. I'll start with a 7, and then I'll multiply all of the natural numbers down to 1. And if we multiply 6 factorial times 7 factorial, we're multiplying all of these numbers all together. Not really sure how big that number is going to be, but maybe in the hundred thousands or millions. I don't really know. But it's some number out there, and hopefully that number is also a factorial number. Now, I'd rather not do all that multiplication. Instead, I just want to see if I can use these numbers to craft the next numbers in the sequence of multiplying larger and larger natural numbers. So I could grab all of these numbers, 1 times 2 times 3, all the way up to 7. And then the next number that I want to multiply would be an 8. And so I'll see if I can get an 8 out of the numbers here in 6 factorial. Well, fortunately, 2 times 4 is 8, so that's where I'm producing the 8. Then I need to make a 9, so I could do 3 times 3. I'm borrowing a 3 from that 6. I'll turn it into a 2. 3 times 3 is 9. And then now I'm just left over with a 2 and a 5, and 2 times 5 is 10. So cool. And then this, by just definition, is 10 factorial. So I don't really need to know what 10 factorial is to say that 6 factorial times 7 factorial is 10 factorial. So that's the problem. We're all done. How about, just for kicks, let's run through the arithmetic real quick and figure out what 10 factorial is. 1 times 2 is 2, times 3 is 6, times 4 is 24, times 5 is 120, times 6 is 720, and now I really need to start doing the multiplication. I could do 72 times 7 and just tack on a 0 at the end. 7 times 2 is 14, and then 7 times 7 plus the 1 is a 50. So 7 factorial is 5040. Then I'll do something similar. We'll do just 504 times 8, but then I'll just remember to tack on a 0 here. 8 times 4 is 32. 8 times 0 doesn't do anything. Add the 3 though. And then 8 times 5 is 40. So this right here is 8 factorial. You know what? I'm going to multiply the 10 in first. So there we go. And then finally, let's multiply by the 9. And then, like before, I'm just going to put those zeros on at the end. 9 times 2 is 18. Carry the 1. 9 times 3 is 27. Add the 1. That's 28. The 0 doesn't do anything. I'll just drop down the 2. And then 9 times 4 is 36. So we do get something in the millions, I guess, kind of like I predicted. 10 factorial is 3,628,800. Not that we needed to know that, but I figured it'd be kind of fun to see what that number is. Ultimately, both sides of this equation, once x is equal to 10, will match this number down here. Okay, we're all done. Bye.